Good morning, pre-calc. Today we're going to be talking about 8.1.2, which is rational function redux. Within this lesson, there are a couple of core problems, and those are 8-18 to 8-23, which let me go ahead and write them up on here. And let's go with green. So, 8-18, if I could draw an 18, to 23 is what we're going to be working on. And as you have here, I have 8-18 pulled up. So what we're looking at is we're looking at sort of, just to remind everyone, a rational function is basically a polynomial divided by a polynomial. Earlier in Chapter 5, we considered some rational functions where both numerator and denominator contained linear functions. Now we're going to be looking at some more complex things. So in 8-18, it says in your teams, but kind of hard to be in your teams when you're all separated by large buildings. So you have three different limits. You have the limit of x approaches infinity of 2 to the x cubed minus x squared divided by x cubed plus 3x. The limit as x approaches infinity of 2x minus 1 over x plus 3 over x. And thirdly, you have the limit as x approaches infinity of 2 minus 1 over x divided by 1 plus 3 over x squared. So looking at these first, which of these limits would be easiest to evaluate without a calculator, and why do you think so? So in my mind, we have a couple of different things. Yesterday, or in the previous video, I was talking about how it really just involves the dominant term, and one of the things that we do in this lesson is we sort of show why the dominant term matters most. So if you're like me, I'm pretty sure most of you would say that number 3 would be the easiest, because when we have if we have the limit as x approaches infinity of 1 over x to the n, where n is greater than or equal to 1, well, I guess actually technically greater than or equal to 0, as it gets bigger and bigger and bigger, or actually I should just say greater than 0. I could get that out in post-op, but why bother? For n is greater than 0, basically it's always going to have a shape of, if we do a quick sketch of it, it's always going to have this as sort of the general shape. So it's going to go towards 0 as x gets bigger and bigger and bigger. So when we look at this one, for number 3, well, we have two terms in it. We have the 1 over x right here, and we have the 3 over x squared. And both of those, because they're of this form of 1 over x to the n, they're going to end up becoming 0. So in that third one, without a calculator, we're going to be able to just sort of make it as limit as x approaches infinity of 2 minus 1 over x divided by 1 plus 3 over x squared, and we have these two sections are going to go to 0, and then we end up with sort of rewriting our limit as limit as x approaches infinity of 2 minus 0 over 1 plus 0, which when we look at this ends up meaning our limit is just 2. Now that's a pretty quick way. However, when we take a look at these different limits, this one and this one and this one are all actually the same limit. Now, if we sort of scroll back up here, one of the ways we can do that, to sort of prove that, is if we, did not mean to do that, if we look at this limit as x approaches infinity of this one, we can actually divide by our dominant term to sort of show how we do that. So in this case, we're going to divide everything by x cubed. And when we do that, I'm going to choose a thinner marker. Let me actually hide this. And when we do that, what we're going to end up with is we're going to divide each term, except for the limit itself, by x cubed. So we have limit as x approaches infinity of 2 x cubed over x cubed minus x squared over x cubed divided by x cubed over x cubed minus 3x over x cubed. And so when we do this, we end up with each term sort of becoming a new term with a fraction on it. So what we'll do is this one, x cubed over x cubed, this becomes just 1. 2x cubed over x cubed, this would end up just becoming 2. X squared over x cubed, this would end up being 1 over x. And then 3x over x cubed, this would end up becoming 3 over x squared. And so we end up rewriting it, which I'm going to drag myself a little bit further over, as limit as x approaches infinity of 2 minus 1 over x all over 1 minus 3 over x squared. And so this is our sort of resultant, and if we look back over to number 3, which let me pull it back up again, it looks very similar. In fact, except I think I got a plus. I mixed up a plus and a minus. Yes, I did. I mixed up a plus and a minus. Whoopsie. Boop. Boop. And then boop. Mistakes were made. Alright, so since we solved it like that, it just sort of shows the equivalency. So when you go on down to, if we go over to 3.8-19, you can explain how to change this function into this. Now with that, the basic idea would be you're sort of changing all of your x components, all of your x's into versions of either whole numbers or numbers and then also functions 1 over x. And you can do this in this particular case. Give you a moment to process it. You have x minus 2x squared divided by 5x cubed minus 7 into 1 over x squared minus 2x over 5 minus 7 over x cubed. To do this, you'd want to divide by the largest term you have, which in this case, in both top and bottom, the largest term is x cubed. So you do that, you end up converting to this, and if you took the limit of it, you'd be able to quickly tell, like, this top term goes to 0, this top term goes to 0, this one goes to 0, and this stays as 5. So you end up with 0 over 5, and that just sort of ends where it is. And then in 8-20, you're looking at sum again, which I believe you all can solve and should be able to do successfully. Fingers crossed. And then lastly, and then you can keep using that and sort of looking back over your results from 8-20, you're trying to figure out some rules for yourself of how to solve it completely, and sort of create these general rules for yourself, so then you'll be able to solve them quickly in the future. So if we look at 8-22, you're sort of doing the same thing, except now it's a little bit more complicated things, and maybe you won't need to do the division to help you figure it all out. And then lastly, number 23 is you're going to have to refer to the race you had with the different terms in 8.1.1, and then just apply it based on which ones grow the fastest in each of these cases. You might have to do some simplification in order to solve it, but I believe in you all. And as for that, that is everything we're going to be covering today. And I will see you all next week or in the next video. Feel free to comment on the video if you have questions. Message me on Jupiter or email me or through Hangouts to get additional help. My office hours are between 10 and 11 and 1 and 2 every day, Monday through Friday. Just message me when you want to get on.